I'm making this video on behalf of a student who needs help studying for her Algebra 2 test coming up this week. Question 1, we got to sketch and graph this function, and we got to find the vertex, domain, and range for that function. So what we have here is f of x is equal to the absolute value of x minus 2 plus 3. So the graphs of absolute value functions are either going to look like a v or an a. So how do you know if it looks like a v or an a? Well, if the coefficient of the absolute value is a positive, then the graph will look like a v. So if the coefficient is negative for this absolute value, the graph is going to look like an A. It's going to open downward. So I'm going to add arrows here to indicate that it continues. In this function, I know that the graph is going to open upward since the coefficient of this absolute value is 1. And we know that 1 is positive. So therefore, the graph is going to look like a V. It's going to open upward into positive infinity. There is an easy way to find the vertex of this function, and this is very similar to vertex form. You want to set this inside part, so don't even look at the absolute values, just set x minus 2 equal to 0. This negative 2, it tells us that the graph is going to shift right 2 units. If this were a positive 2, then the graph would shift left 2 units. So this positive 3 up here, it tells us that the graph is going to shift up 3 units. If it were negative, then the graph would shift down 3 units. So to find a vertex, we've got to set the inside equal to 0. So if you add 2 over, x is going to be equal to positive 2. So we know that positive 2 is going to be our x-coordinate of the vertex. Now, the y-coordinate, that's simply the number that's outside of this absolute value to the right. So it's going to be this absolute value and then plus 3. So the y-coordinate would simply be a positive 3 for the vertex. Now, once we have the vertex, we can plot this on the graph. So 2, 3 is going to be right here. And I know that the graph is going to open upward. So it's going to look like a V starting from this position. 2, 3. So I know that the graph is going to branch off at 2, 3. So it's going to be the midpoint of this absolute value function. So now we need to find where the graph hits. Now you can do this by plugging in different numbers and finding the shape of the graph. So we can plug in a number that is next to 2 on both sides. So what I mean by that is we can plug in 1 and then 3. So you always want to plug in numbers that are next to the x-coordinate of the vertex. So we can plug in 1 and 3. So we can also plug in 0 and then 4. So we're going up 2 units. We're plugging in numbers that are next to 2 by 1 unit. And then we're going to plug in numbers next to 2 by adding or subtracting from 2. So 0 and 4. So if you plug in 1 into this equation, 1 minus 2 is equal to negative 1, and the absolute value of negative 1 is positive 1. And then positive 1 plus 3 is positive 4. So plugging in 3 now, 3 minus 2 is equal to 1. Absolute value of 1 is still positive 1. And then 1 plus 3 is still 4. And then if you plug in 0, 0 minus 2 is equal to negative 2. The absolute value of negative 2 is 2. And then 2 plus 3 is equal to 5. Now if you plug in 4, 4 minus 2 is equal to positive 2. The absolute value of positive 2 is still going to be positive 2. And then positive 2 plus 3 is going to be equal to 5. Now we can plot in these points to find what the graph looks like. Now 1, 4, we can plug in this, and that'll be right here. 3, 4, that's going to be right here. 0, 5, that's going to be right here. And then 4, 5, that'll be right here. So the graph will look like this. As you can see, it's a V, and they branch off at the vertex. So both sides spread out at this point. Now we can draw a line through it. And then that'll be your graph for question number 1. So the domain, that's the numbers that the graph approaches. So I know that the graph is going to keep going to negative infinity. And then the graph on this side, it'll keep going until positive infinity. So the domain would be negative infinity, comma, infinity. You would always use parentheses for infinity signs. Now the range, that's basically the smallest y value, comma, the largest y value. The smallest y value in this case would be positive 3, since y is equal to positive 3. That's our smallest y value for this function. The largest y values would be positive infinity, since they spread out and they keep going infinitely. It will be a bracket 3, since 3 is included in this function. And then comma, infinity, and then parentheses. So that'll be your final answer for question number 1. Alright, for question number 2, we got 1 over 3, so 1/3 times the absolute value of x minus 2. So right away, I know that the graph is going to look like a V, since the coefficient of this absolute value is a positive. 1/3 is a positive number. So it's going to look like this rather than this. So to find the vertex, you got to look at the number that's inside the absolute value. And then you got to look at the number that's outside the absolute value to the right. So the x-coordinate, you just got to set the inside term of the absolute value equal to 0. So in this case, x is going to be equal to 0. So that's our x-coordinate of the vertex. And then our y-coordinate would just be negative 2. We can plot this vertex onto the graph. So it'll be right there. Now, I know this vertex, the graph is going to spread out like this on both sides, starting from that vertex, from that point. So to find the shape of the graph, I'm going to plug in 4 different points. Now, I would plug in negative 3 and positive 3, since those work out to become a whole number. Negative 3 and positive 3. I would also plug in negative 6 and positive 6. If you plug in negative 3, the absolute value of negative 3 is positive 3. And then 1 over 3 times 3 is going to be 1. And 1 minus 2 is going to be negative 1. So if you plug in 3, the y-coordinate will also be negative 1. If you plug in negative 6, so the absolute value of negative 6 is positive 6. And 1/3 times positive 6 is going to be 2. And 2 minus 2 is equal to 0. If you plug in positive 6, well, the absolute value of positive 6 is still positive 6. And 1/3 times positive 6 is equal to 2. And 2 minus 2 is also equal to 0. So you can plot these points onto the graph to find what the slope is on both sides. So negative 3 comma negative 1, that's going to be right here. 3 comma negative 1, that would be right here. Negative 6 comma 0, that's going to be right there. And then 6 comma 0 will be right here. So your graph will look like this. So the domain will be all real numbers, since the graph approaches negative infinity on the negative side, and then the graph approaches infinity on the positive side. So the domain will be negative infinity, comma infinity. And then the range of the graph, so smallest y value first, comma the largest. So the smallest y value would be negative 2, and that will be in brackets since negative 2 is included. And then comma, infinity, and infinity will always be in parentheses. So that's our final answer for question number 2. Alright, so question 3, we got to sketch and graph this function, and we also have to find the vertex, domain, and range. So similar to questions 1 and 2. So right away, I know that this function is going to open downward like this, like an A. Since the coefficient of this absolute value is a negative. So it's going to look like this instead of this. So define a vertex. Set the inside of the absolute value equal to 0. So x plus 5 is equal to 0. And that would be x is equal to negative 5. Now, negative 5 will be our x-coordinate of the vertex. And then the y-coordinate would be negative 4. So we can plot this vertex onto the graph. So negative 5 comma negative 4, that'll put us right here. Now, I want to plug in 4 different points that are next to negative 5. So we can do negative 6, negative 4, and then we can also do negative 7, and then negative 3. So plugging in negative 6, negative 6 plus 5 is equal to negative 1, and absolute value of negative 1 is positive 1. So we would have negative 2 times positive 1 minus 4. And negative 2 times positive 1 is equal to negative 2. And negative 2 minus 4, that would just be negative 6. So if you plug in negative 4, you would have the absolute value of 1 inside. And the absolute value of 1 is still positive 1. And you would have negative 2 times positive 1 minus 4. That would just be negative 6. The numbers that are like next to 5, so if it's like greater than 5 by 1 and then less than 5 by 1, the y-coordinates for those points will be the exact same. It should be, or else you're not doing it correctly. So if you plug in negative 7 plus 5 is equal to negative 2. And the absolute value of negative 2 is positive 2. Now we have negative 2 times 2, which is equal to negative 4. And negative 4 minus 4 is equal to negative 8. So for this negative 3, the y should also be negative 8. But let's double check. So negative 3 plus 5, that'll be positive 2. And the absolute value of positive 2 is still positive 2. And so we have negative 2 times 2, which is negative 4. And negative 4 minus 4 is equal to negative 8. So they are all equal here. Alright, now we can plot these points onto the graph. So negative 6 comma negative 6. That'll put you right here on the graph. Negative 4 comma negative 6. That'll be right here. Negative 3 comma negative 8. That'll be right here. And then negative 7 comma negative 8. That'll be right here. So the graph, like I said, it's open downwards. So it's going to look like that. So domain, that will still be all real numbers since it continues to infinities. And for range, that would be negative infinity, comma, negative 4, and that's in brackets since negative 4 is included. Alright? So moving on to question number 4. We have f of x is equal to negative 2/3 times the absolute value of x. So right away I know this graph is going to open downwards since the coefficient is negative. Look at that sign right there. Alright, so it's going to look like that. Now to find the vertex, set the inside of the absolute value equal to 0. So x is just going to be equal to 0. And then the outside number, there is none. So the y-coordinate would just be 0. So the vertex would just be at the origin. So to find the shape of the graph, I'll just plug in 4 different points that are equal distance away from the x-coordinate of 0 of the vertex. In this case, I would plug in negative 3 and positive 3 since those work out to become a whole number because you're multiplying by negative 2 over 3. So let's plug in negative 3 and 3. And let's also plug in negative 6 and positive 6. So plugging in negative 3, the absolute value of negative 3 is positive 3. And then negative 2 over 3 times 3, that's going to be equal to negative 2. So if you plug in 3, the absolute value of 3 is still equal to positive 3. And that would also get you negative 2. Now if you plug in negative 6, let's write that out. The absolute value of negative 6 is equal to positive 6. So you would have negative 2 over 3 times 6. And that is equal to negative 4. If you plug in positive 6, you would also get negative 4 for the y-coordinate. Now you can plot these points on the graph to determine the shape of the graph. Now negative 3 comma negative 2, that point gets you right here. And 3 comma negative 2, that would be right here. Negative 6 comma negative 4, that would end you right here. And then 6 comma negative 4, that would be right here. Now we can draw a line through these graphs, through these points. There you go. That's your graph right there. Now domain and range. The domain would be all real numbers since it continues to infinities. Negative infinity on this side, positive infinity. So that would be negative infinity comma infinity. And then range, that would be negative infinity because it continues to negatives on both sides, comma, the largest y value, which is equal to 0. So that's going to be in brackets since 0 is included in this function. So that would be your final answers for number 4. I hope this helped. If you guys want to see the whole sheet, here you go. So the whole sheet will be posted online, but you can take a photo of the sheet right now. These are all the answers to all 4 problems. So I hope this helped, guys. Like and subscribe. Make sure to comment and then fill out the video request form to request a video upload in the future.